Good morning, class. This is Tim Tomlanovich. Hope you're doing well. This is lecture learning plan 3 for Intro to Civil. So let's talk about scaling. Architect and engineer scale. Okay, so we have two different types because this is how we build and construct things. So let's go to the slideshow here and we'll do a brief introduction here, and then what we'll do is we'll do some examples and then you'll be able to complete your assignment. All right, so architect versus engineering scale. Okay, architect, typically what we are in is feet and inches. Feet and inches, okay? All right, in civil, we are in decimal feet. So you gotta be able to convert back and forth, okay? So if I look at this plan here, finished floor, 0 feet dash 0 inches. That's architectural, okay? Now if I go to civil, you see it's 51.25 feet. That's the civil, okay? The 51 is probably some local elevation datum, right? We know the elevation of sea level is 0.00 feet, decimal feet, right? Okay, 0.25, that is a quarter of a foot, okay? So what they do in architectural is they'll assume a finished floor is 100 feet 0 inches. So that just makes life easy, okay? So that's the main difference. Architect is feet and inches, civil is decimal feet. So you gotta be able to convert back and forth, okay? All right, so let's look at the architect scales. So if you look here, okay, we have, they call this a 16 scale. So what I'm going to do, the 16 scale is also a full scale. That is actually a full inch, okay? This is not scale. So from 0 to 1, I'll use my little, from 0 to 1 is 1 inch. From 1 to 2 is 2 inch. 3, 4, 5, 6. So this is not scale. This is the same as a normal ruler. So let me go to a normal ruler. So let me escape and go to the document cam here. All right, so if I look here, let's see if I can zoom in. Autofocus. Focus lock. Okay, so here's my 16 scale. Okay? All right, we'll do that one more time. All right, now if I throw this across, okay, I'm just going to kind of turn things here so we can see both at the same time. I'll put this on this side. All right, so if I look here, if I line the 3, here, let me do this. I'm going to make this bigger. I'm going to line the 3 up to the 3. So if I look here, so we'll go 5 and 6 so you can see it. So I got to rotate this so you can see it. All right. As you can see, on a normal tape measure, 5 to 6, that's 1 inch. 5 to 6, this is 1 inch. Okay? So let's start talking about fractions now. Let me zoom in a little bit. No, there we go. Okay? So, fractions. So, halfway point here, would you say this is half an inch? So, from here, right here is 5.5 inches. Okay? So, if that's a half, what are these then? Okay? So, we have an eighth, 2/8, 3/8, 4/8. 4/8 rounds to 1/2. 5/8, 6/8, 7/8, 8/8. 8/8 equals 1, so that's why we get 6. It's the same as a normal ruler. As you can look here, we have 1/8, 1/8, 2/8, which equals a quarter, 3/8, 1/2. Okay, this is on the 5. Okay, 1/2. Okay, 3/8, or 5/8. 5/8, 6/8, which is 3/4, 7/8, and 8/8. Okay? So in between the eighth is what? This is an eighth, so that means that each one of these is a 16th. So again, so if this is an eighth, half of an eighth is a 16th. So I just wanted you to compare that this is a normal, the 16 scale right here, as you can see, is normal inches. Okay? And just think of fractions, all right? It's a normal tape measure, it's inches, okay? So going back to that, okay? All right, so we'll go back to the PowerPoint. Okay, so that is that. So now we have these different kind of scales. We have 1/2, we have 1/8, we have 1, we have 1/4, we have 1/8. So what that is representing, we have 1.5 inches. What that is representing is 1/8 of an inch equals 1 foot. So basically what they do is they take this 12 inches here, 12 inches equals 1 foot. Just remember that, 12 inches equals 1 foot. That will never change. They're taking these 12 inches and they're squeezing it down into, from the 0 mark down to here. So that is literally 1/2 of an inch, okay? So right here, they're taking this 0 to 12 inches, which is not scaled down, shrinking it down, and they're making this represent 12 inches. So, okay, so that's why we have different scales, and I'll go into further detail, all right? So, basically, if I look at my scales, I have 0, I'm going to use my little laser pointer here, 3/32. 1, 2, 3, 4. So that's 4 feet. So on the right side of the 0 is feet, and on the left side is inches. Same thing on an 1/8. 1/8 inch equals 1 foot. Feet, inches. So 3/4 of a real size inch equals 1 foot. Okay? 1 inch, 1.5 inches. So let me go back to the ruler so you can see this. Okay, so I'm going to open up my ruler. Okay, so from here to here is 1 inch, right? Okay, so from here to here is 1/2 inch. So what I'm saying is that from here to here is 1/2 inch. That is actually, we're shrinking, that's actually now going to represent 1 foot. We're scaling it down, okay? So 1/4 inch is right here. And 1/8, 2/8, or 2/8 equals 1/4, or 1, 2, 3, 4, 16ths equals 1/4, using fractions. So 1/4 equals a foot. So basically the real life distance of 1/4 inch is now going to represent 1 foot. Okay? So hopefully that kind of helps what we're doing here. All right. Okay? Okay. How do I figure out the value of each tick mark? You count the number of divisions between 0 and 1. Between 0 and 1. There, each tick mark is 1/16 of an inch. So there is 16 tick marks between here or here, or 16 spaces. So 16 equals 1 inch. Fractions, okay? Now we could go, well, what happens if we're between 2 tick marks? So basically, we calculate 1/2 of the value of the smallest tick mark. So 1/16 divided by 2 is 1/32. 2/32 is 1/16. Okay? So basically, what it is, so I know each of these tick marks is 1/16, so 1/2 of a 16th is a 32nd. So if my line falls in between 2 tick marks, because I know each one of these is 1/16, I know it has to be 30 seconds. So if I go to this one here, this is 6 inches, 6, this is 6.5, right? But so 1/2 inch equals, okay, equals 8/16, right? So 8/16 equals 16 30-seconds. Okay, so now I know I gotta add one more because I'm a little bit over 6 and 17 30-seconds. So let me do that math for you. So let me go actually use the scale. All right, so let's go to this guy. Okay, let me zoom out a little bit. All right. Okay, 8. Okay, zoom in. Slide this over. 6, what do we want? Okay, 6. So I'm going to draw a line from 0 to 6 and 17/30 seconds. Right there. Okay? Alright, let me just autofocus in. Okay, so I have 6, right? So I know this is 1, 2, 3, 4, 5, 6, 7, 8. It's between 8/16 and 9/16. Between 8/16 and 9/16. That's where that line falls, right? 8/16 reduces down to 1/2. Okay? However, we know we can only go accuracy as a half. So I want to convert 8/16 into 30 seconds. 8/16 blank over 32, right? What does that mean? 32 divided by 16 is 2 times 2 is what? 16. Okay? All right. We know 9/16. Oops, so you can see here. 30 seconds. That equals 18, right? 32 divided by 16 is 2 times 9 is 18. So when I go back to this measurement, so basically it is between 16 30 seconds and 18 30 seconds because I converted it from 16ths to 30 seconds. Now I'm halfway between 16 and 18, so that's where I get 6 and 17 30 seconds of an inch. So, all right. So I want to, this is a quarter, right? I know there's 4 quarters per inch. Okay, there's 8 eighths in an inch. There's 16 sixteenths in an inch. So if you just kind of remember fractions, that should help you. So this takes practice, okay? So that's how that scale works. When I'm on full scale, or they call it a 16 scale, we're not scaling anything. So hopefully that'll help a little bit. All right. So okay. All right. So how long is this line? Let's see. I was just there. So 1 inch, 2 inch. All right. So remember, each one of these is a 16th. So that's an eighth, 2 eighths, 3 eighths, 3 eighths. That's 4 eighths. 4 eighths equals a half. So 3 eighths. Okay. So looks like I'm at a 16th here. So 3 eighths. How many eighths is 3 eighths? That is what? 6 sixteenths, right? That's 7 sixteenths. This is 8 sixteenths. Okay? So this is so it's between 7 sixteenths and 8 sixteenths. It's actually overhanging between here and here. So I know my answer is between 7 sixteenths and 8 sixteenths. Okay, so I need to find the midpoint between that. So first I got to go into, so this is 14 30 seconds, this is 16 30 seconds. First thing I do is convert it into 30 seconds because I know half of my sixteenths, right? 7 times 2 is 14, 8 times 2 is 16. So halfway point is 15 30 seconds of an inch. Okay, so go back to the slide, right? So we have 15 30 seconds of an inch, okay? And we have 2 and 15 30 seconds of an inch, okay? So that's what that one is. Okay? All right. All right. So if you look at here, this is a full quarter inch. 1 16th, 2 16ths, 3 16ths, 4 16ths. 4 16ths equals 1 quarter, or 2 eighths equals a quarter. Okay? Now, if I look down here at my 1/4 inch equals a foot scale, okay, as you can see in real life, from here to here is a 1/4 inch on the non-scale, the 16 scale. So that is actually a 1/4 inch. Now, knowing 1/4 inch equals 1 foot, so I know all of these tick marks equal, there's a foot between here and there, okay? So how do I figure out what's the value of each tick mark? Okay, so you can either count every single one and divide it by 12, okay? Or you can go, we know this is 6 inches, right? So half of 12 is 6, so we know that's the halfway mark, that's 6 inches. So that's 3 inches, so obviously I can't see this, and I'll blow this up. We can figure out how much that is, okay? So I'm gonna go, let's see. I'm gonna go do these on, so I'm gonna go look at the 1/4 inch equals a foot and the 1/8 inch equals a foot. I'll do these for accuracy of scales, okay? So read this over here on the right. All right, I'm gonna turn this over. All right, so we find 1/4 inch equals a foot. Right here. Let's zoom in. Okay, so just so you know, I have some videos in there that will help, hopefully, with this. Okay, so autofocus lock. All right, so if I look at my 1/4 inch from here, so if I look at this number here and I look at this number here, see these numbers are the same, so this is another 1/4, this is another 1/4, so that's 2 feet, okay? All right, so how do I know how many, what is each of these values? So I know from here to here is 12 inches, okay? So half of 12 is right here, so that's 6 inches. Half of 6 inches is 3 inches. So if I look there, I actually have 1, 2, 3. So each of these tick marks is 1 inch. Okay? So I gotta take my glasses off now because I can't see. So now what I'm going to do is actually count all the spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 divided by 12 equals 1, so that means each tick mark is 1 inch. But I like this method. This is half, that's 6, this is another half, that's 3, and I keep going back to 0, so that's 2, that's 1, that's 0. So each tick mark is 1 inch, okay? So if my line falls in between one of these, what is the difference if it falls, my line falls between the 1 inch and 2 inch, so my accuracy can only be 1/2 inch, so I can have 1. So if my line falls between 1 inch and 2 inch, I can have 1.5 inches, 2 inches, 2.5 inches, 3 inches, because my accuracy is only half of the distance between the two smallest tick marks. Okay, let's do 1/8 inch. So if I slide this over, here's 1/8 inch. Okay, again, 0, 1, 2, 3, 4. 4 feet, okay? So from here to here, again, we're squishing 12 inches into here. So that's the 6 inch mark, right? Okay, so 12, that's 6, 4, 2, 0, right? So you just figure out, so each tick mark is actually worth 2 inches. Can I also do that? I'm going to count the spaces. 1, 2, 3, 4, 5, 6. 6 spaces. 12 divided by 6 equals 2. So each tick mark is 2 inches. Okay? So if I know, so each tick mark is worth 2 inches. 2 inches, so if I go to the next tick mark, which is 4 inches, okay, so my accuracy, I know the space between them is 2 inches. My accuracy is only 1 inch, so I can go 2 inches, 3 inches, 4 inches, 5 inches. So you notice the accuracy of the 1/4 was 1/2. Now our accuracy is only 1. because it's smaller. Okay, let's do one more. Let's do 1.5 inches. Okay, all right, 1.5 inches. Let me, 1.5 inches equals 1 foot. All right, this one's a little easier. So if I look here, 0, 2, or 2, or is this it? Is this 2 feet? Is this 1 foot? So basically what you do, this distance right here to right here, okay? Does this distance look the same as that distance? So this is actually 1 foot, and this is actually 2 feet. This 2 actually is from this scale going backwards, okay? All right, so how do I know the accuracy? All right, so it kind of tells me, I find my 1 inch. So I know this is 3, this is 2, this is 1, right? 1, 2, 3, okay? So if I know from there is 1, so 1/2 of 1 inch is a 1/2 inch. So I know this tick mark is a 1/2 inch, okay? If that tick mark is a 1/2 inch, what's 1/2 of a 1/2? 1/2 times 1/2 equals 1/4, right? Multiply top, multiply bottom. Okay? So that's a quarter, so that means 1/2 of a quarter is 1/8. So each tick mark is 1/8. Okay? So 1/2 of an 1/8 is a 16th. So that's if I fall between this, the first tick mark and 0. If my line falls in between halfway between there, that means I have 1/16 of an inch. Okay? So that's the architect scale. All right. So hopefully this will be a little clearer when I go to the homework assignment. All right. So how do I measure a line? Okay, so we did the accuracy. How do I measure a line? Okay, 1, determine the accuracy. Okay, so I'm measuring this line. I know I'm at 3/4 from here to here is 12 inches. That's a real life 3/4 of an inch. So if this is 3, this is 2, this is 1, so that's 1/2 inch. So halfway between that point and this point is a 1/4 inch. So each tick mark value is 1/2 inch, therefore the accuracy is a 1/4 inch. So I place the scale at the beginning of the line at 0, okay, and then I find it to the nearest whole tick mark, okay. So if you look here, it falls between 2 and 3. So I have 2 feet and some inches. Okay, remember from 2 feet to 3 feet, this is 12 inches. So it's not quite 3 feet, so it's 2 feet and some inches, right? Okay, then what I do is, I slide the ruler to the right side of the line at the 2 foot mark. Because if you remember, look here, 2 to 3, it's not there, okay? Then I know it's 2 feet plus how many inches? So if I look, I have 0, 3, 6, 9. It's about at the 9, so I'd say I could call that 2 foot 9 inches, right? Is this 2 feet 8 inches? This is 2 foot 8.5 inch. So if I really wanted to be picky, halfway in between, it'd be 2 feet 8 3/4 of an inch. Okay? And that's what I get because it falls, doesn't quite hit the 9, it doesn't quite hit the 8, so it's halfway in between. Okay? So that is the answer to that on an architect scale. All right, so let's go over the homework a little bit. Okay. So I have practice. Oh, there it is. Okay, so here's scaling practice, and here's your assignment. They're two different. So what I did is, what you're going to do, right here, let me zoom out, is I have the answers posted in Blackboard. I have the answers posted in Blackboard. Okay, now they may be a little bit different because depending how I print this thing out, the scale may change. So what I want you to do, the full size 16, okay, is I want you to determine the accuracy and I want you to measure this line, okay, and you're going to letter everything, right? Okay, so I'll do the first one. So you're going to grab your architect scale, okay, all right, so I'll zoom in. So this is practice, okay? All right. So I need to figure out what each tick mark is again, okay? So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. There's 16 spaces, okay? So that means there is 16 spaces. So each tick mark is a 1/16 of an inch because from here to here is 1 inch, okay? So if I know from here to here is 1/16, if I fall in between, that means it's 1/32. So my accuracy is 1/32 of an inch. Line length, okay, let's measure this thing. In the full scale, I do not have to move it. I put my line on the 0, okay? I'm over here. Hopefully you can see me. Just make sure you can see what I'm doing here. Okay, my line, see my ruler's at 0. So I know I have 5 inches, 5 1/8, 5 1/4. I'm gonna have to say that is right on this line. So 1, 2, 3, 4, 5/16. So I'm gonna write down 5 dash and 5. It's okay to erase 5 and 5/16 of an inch. Okay, this is the inch mark. The 2 little dash, that's inches. 5 and 5/16 of an inch. That's how I did that one. All right, let me do one. Let's do 1/2 inch equals 1 foot for another scaling practice. Okay, so I find my 1/2 inch. All right. Okay, here's my 1/2 inch scale. First of all, I got to figure out my accuracy, right? So I'm doing 1/2 inch equals 1 foot. All right. So from here to here, I know there's 12 inches. Okay. So halfway between is what? Right there? Is that 6? That's 3, that's 0. So 1, 2, 3. So each one of these bigger, this is 1 inch. Okay? And it's hard to see. I'm doing the best I can. It's hard when I can't see and then you're trying to see. So 6, 3, 2, 1, 0. So if this is 1, that longer one, that means this one is a 1/2 inch. Okay? So 1/2 of a 1/2 inch is 1/4. So my accuracy is 1/4. Okay? So that is 1/2 inch equals a foot. So my accuracy is 1/4 of an inch. So I can only measure to the nearest 1/4 inch. Okay, now let's measure my line with the 1/2 inch scale. Okay, let's get the line here. Let me zoom out. Okay, so I start at 0. Okay, make sure you can see what I'm doing here. I start at 0. So I know I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, almost to 11. Between 10 and 11. Okay? So I know I'm 10 feet something. 10 feet and change. So I bring it, okay, again, I started at 0. I know it went to the nearest whole foot is 10 feet. It's not quite to 11. Okay, so I slide the ruler back to 10 feet. Okay. All right. And then this is 6 inches, so 10 feet, 6 inches. This is 1, 2, 3, 4, 5, 6, 7, I'm going to say 7.5. It's right on the tick mark between the 7 and 8. It's 7.5. So I'm going to write that down. 10 feet dash 7.5 inch. 10 feet 7.5 inch. So that was the half-inch scale. Okay? So that's practice. All right? So, all right, I know this is going to be tough, so that's why I want you to come see me if you're struggling. All right, so that's the practice. So I'm going to cover architects and then I'll cover engineering. Okay? All right. So, here's my assignment. So basically, what I want you to do is measure this line in architect scale. 3/16 equals 1 foot, right? All the way, so I want you to use all these scales to measure it, okay? You're gonna measure this line and write down, you don't have to write down the accuracy, but you're gonna write down your answers right there, okay? If you want, nice and neat, if you wanna figure out the accuracy to the left, that's fine, as long as it's nice and neat, okay? So that's what you're going to do for your assignment. And then when you get to the back side, okay, I'm actually going to draw a line using 3/16 equals 1 foot. Draw a line 15 feet 6 inches, okay? So let's do that quick so you can get an example of that. Well, I'll do that all at the end, okay? I'll do a couple at the end here just so you get a practice. All right, so that is architect scale. Just remember, there's 12 inches per foot, and remember, only one that I'm not scaling is a 16 scale. That is a full. This is a real inch. Any other scale between the 0 and here, between the 0 and there, is 12 inches. I just got to figure out what each tick mark equals, and then my accuracy can only be halfway between the tick marks, okay? So, practice. Architect scale is kind of one of the more difficult ones. All right, so let's talk about engineer scale now. Engineer scale, we're in decimals of feet, okay? So if I look here, 10, 20, 30, 40, 50, 60, okay? I put a 1 here, this actually stands, that equals 10 feet. This equals 20 feet. That equals 30 feet, 40 feet, 50 feet. 20, this is 1 inch. 1 inch equals 20 feet. So see how these line up right here? I'm going to use my, so I just want to show you. I'm going to line, I'm just going to draw a straight line down. This is a real live inch from, okay, from here to here is an inch, okay? So, okay, from here to here is an inch. From there to there is an inch. But if 1 inch equals 10 feet, so at the 1 inch mark, that's 10 feet. At 1 inch equals 20 feet, from 0 to here, that equals 20 feet. At 1 inch equals 30 feet, see, it's the same distance, is 30 feet. So 1, 2, 3, 4, 40 feet, okay? So I'm just adding a 0 at the end of it. So there's always, architect scales or engineering scales are easy. They're divided by 10, which is awesome. So if it ends in a 0, that means each of these tick mark is 1 foot. So this is 5 feet. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So, same here. It just gets smaller. There's 10 tick marks between here and the 1. So if I know, because there's a 0, and I know each tick mark is 1 foot, that means my accuracy is 0.5 feet. 0.5. Right? Half of 1 is 0.5. So my answer is when I have 1 inch equals 10, 20, 30, 40, 50, 60, right? My answer better end in 0.0 or 0.5. Okay? All right. So let's move on to the next slide. All right, so if I look here, survey, this is 1/10 of a foot, okay? 2/10, 3/10, 4/10, 5/10, right? 5/10 or 1/2 a foot equals 6 inches, 0.5. Okay, so here's a full scale. I kind of like this is out of your textbook. Okay, so there are chapters in your textbook that you can read. It helps explain this. Okay, so if I look here, here is 1 inch. Okay, so and 1 inch equals 20 feet. That equals 20 feet. Okay, so this is kind of a nice thing here. This kind of helps you distinguish. So the distance from here to here is 6 inches, is the same distance from here to here, which is 0.5, okay? But, so 0.5 is actually right there on this scale, 0.5 feet, okay? Which is equivalent to 6 inches. All right. So, we can actually make this 1 inch equals 100, 1 inch equals 1 foot, 1 inch equals 1,000 feet, 1 inch equals 100 miles. So literally what we're doing is we can remove this 0 or add zeros. So what we're doing is moving a decimal place to the right, or we're moving it to the left. Okay? So no matter what, whatever scale I am at, the first one, that equals, you go to the 1. No matter what, there's always going to be 10 divisions, right? So if I make this 1 inch equals 1,000 feet, this scale right here, okay, because there's a 1 in front of it, so that's the one I want to say. If 1 inch equals 2,000 feet, then I have to go to the 220 scale, okay? So from here to here is 1,000. 1,000 divided by 10 is 100. So that means each tick mark is now 100. 100, 200, 300, 400, 500. So now, from here to here is 100, so my accuracy now, instead of 0.5, it's actually 50 feet. Okay? So you can kind of see, all right? Let's see here. So I kind of went through this already. Okay, as you can see, if I make this 2,000, right here, so that's 1,000. 1,000 divided by 10 is 100. So my final answer will end in 0, 0, or 50 because my accuracy from here to here is 100. So if I fall in between, that is 50 feet. So let me turn on the lights because I guess I'm not moving enough. Okay. All right. So this represents 1 inch equals 1 foot. Each tick mark is 1/10 of, so if this is 1 foot, see, 10 scale, I'm taking the 0 off. Instead of that being 10, it's 1 foot. So 1 divided by 10 is 0.1. So that means each of these tick marks is now 0.1, and if I fall in between halfway, it's 0.05. So my answer better, if there's no 0 at the end of my scale, I better end in 0.00 or 0.05. So if I look here, 1, 2, 2.1, 2.2. 0. So if this was in between 2.2 and 2.30, it would be right here would be 2.25. Okay? Now, this is 200 feet. Okay? So from here to here, I'm adding a 0 to here. So that means this is 100 feet. 100 divided by 10 is 10 feet. So each of these tick marks is 10 feet, so my accuracy is 5 feet, half of my value of each tick mark. Okay? So my answer has to end in 0 or 5. There's no decimals anymore, is there? When I have 2 zeros at the end of my scale. See, it's a 20, I'm using the 2 scale, but now I have 2 zeros. So when I take the 0, what was my answer? It's going to be 0.0 or 0.5. Now I add a 0, now I have 0 or 5. Now if I add another 0, I'd have 50, 0, 0, or 50. Okay, so now if I look here, 100, 200, 300, 400, 500, 550, okay, 50, 560, okay, 560, halfway between 560, 570, 565 feet. Okay? All right, so a lot covered here. Okay, so let's go to practice. Let's go to the practice sheet. All right. Now, please sit down. If you need me to help sit down and figure this out, please see me. I want you to make sure you actually understand this. So on the practice sheet, now I have engineering scales down here, okay? So 1 inch equals 20. So remember, my engineering scale has the 30, the 20, the 50, okay? So let's do 1 inch equals 20 feet. I'm gonna zoom that in. Okay, so this, the scaling practice you're not turning in. You are using this for practice. Print it out and keep doing it. Print it out and keep doing it. So do it once, check your answers, print it out another blank one, throw everything else away, and do it again. You see if you get the same answers. That's when you know you understand it. All right, 1 inch equals 20. Okay. So this is 10 feet, this is 20 feet. Okay? So if I know this is 10 feet, each tick mark is 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that was really hard to see. I'm going to really zoom that sucker in. Okay? And then what I'm going to do is I'm going to push this up. There we go. Now I'm closer. So I'm doing this one. 1 inch equals 20 feet. That's 10 feet. That's 5 feet, that's 1 foot. So my accuracy, half the distance, half of the value of one tick mark is 0.5. 0.5, okay? Feet, put the little foot mark there, okay? Now, how do I measure this line? This is a lot easier. I don't have to slide it around. I just start at the 0, and then I measure it over here, okay? So, that's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, right? So 100, this is 105. So I'm guessing, I'm looking, 105, 106, it's almost between 106 and 107, so 106.5 feet. 106.5 feet. Now, okay, if it ended right on a tick mark, it would be 106.0 feet or 107.0 feet. Okay, so again, if I look at that, okay, another way you can do this, I know this is 10, right? Just add a 0. So that means I'm at 100 already. So that's 105, 106, 107, halfway between 106 and 107. Okay? All right, let's do 1 inch equals 50 miles. It's the exact same thing as this. My accuracy is going to be 0.5 because I only have 1 0 after it. However, I'm in miles instead of feet. All right? Let's do 1 inch equals 400 practice. All right, so it starts with a 4, right? Okay, 4. Where's my 4? 4. There it is. Found it. All right. So here's 4. So I know this is 1 inch, so that's 40 feet. Here's 10 feet. Right? Or is that 100 feet? Because I have 2 zeros here, right? I have 2 zeros. So this is actually 100 feet. So 100 divided by 10. Each tick mark is 10 feet, and half the value of the tick mark is 5 feet. So my answer can only end in 0 or 5 feet. It has to, okay? So now let's measure this line. Okay. All right, 200, 400. This is 1,000. This is 2,000, right? What am I doing? I'm just adding 2 zeros to it. 2,000. This is 2,000. Let's see here. This is 2,100 right here. 2,100. And 2,100. Okay, 2,000. So what is each tick mark worth? 100. Okay, 100 divided by 10 is 10. Okay, so this is 2,100, 2110, 2120, 2120. 2,120 feet. Okay, so if it was between 100 and, oops, I got a decimal place in the wrong spot. 2,120 feet. So it's either going to enter in a 0 or 5. So my next answer can only be 2,125 or 2,130. So where is that? Where is that number? Okay. So 2,100. Okay. This is 10, 20, 30. So halfway in between there. So I can't see it with my eyes. So maybe you can see it with your eyes. So remember, be close. Just want to make sure you're this is what I'm looking at. Or do I have the right amount of decimal places? Okay. All right. 1 inch equals 6. Let's do that one. So I use the 60 scale. Okay. I use the 60 scale. So this is 1 foot. So that means if this is 1 foot, that means each tick mark 1 divided by 10 is 0.1, and half of a tick mark is 0.05. So 0.05. So you notice what's happening here. 1 0 at the end of my scale, 0.5. 2 zeros, what happened to the decimal place? It moved to the right, 5. My 0 goes away, I go from 0.5 and I move my decimal place to the left. I get 0.05. So now my answer here, because there's no 0 at the end of my scale, my answer has to end in 0.00 or 0.05. Okay, so now let's measure that. Use the 60 scale, which is 1 inch equals 6 feet. Okay, so that's actually 30, almost 32 feet. I gotta take off my glasses. It's not quite 32 feet, so it's 28, 29, 30, 31. So here's 31 feet. This is 31.5 feet. Okay? So I'm going to say this is 31.9. I'm going to say it's in between. So it's 31.95 feet. Right? No zeros. The 0 is gone. So that means this is 4, this is 1. So that means I don't have to add any zeros. Okay? You probably couldn't see me write that down, but I think you saw me measure it. All right, so architect scale. So you notice there's no feet or inches in the engineering scale. There's feet and inches in the architect scale. Okay. All right. So with that, okay, let's go to your assignment. Okay. So what you're going to do, you're going to print this out. I want you to put your answers right on this. Okay. So I want you to measure this line with 1/8 of all of these scales. Don't forget this guy. Okay, I'm just going to pick one here. Let's do 1/8 inch equals 1 foot. I'll just do an example. It's going to be nice and neat. You're going to put your name up here, right? And letter it. Okay, nice and neat. Well, mine's kind of crooked. I'm trying to look and make sure you can see what I'm writing, which you couldn't see, so sometimes it helps just to tape down your sheet. All right, architect scale. 1/8 inch equals 1 foot, so architect scale. I find my 1/8 inch, put her on here. Okay, so I start at the 0, I go to the nearest foot mark, so here's 44, 45, 46, 47, 48. So it's between 45 and 46 feet. All right, so I already know I have 46 feet and change. 46 feet dash, right? Because I'm going to have inches. Okay, so now I slide it to, okay, oh, I'm sorry, it's 40, because I'm over 45, but I'm not to 40, I'm not quite to 46, so I got to slide it back to the nearest foot, which is 45, not 46. All right, and if I look at that, that's 45 feet 0, 45 foot 2, 45 foot 4 inches. Okay. Again, go back to the nearest whole foot. 45 feet 4 inches. Okay. All right. So, all right. Because what happens? Right, I know each tick mark is 2. That's the first mental step you got to do. What is my tick mark? I know that's, excuse me, 1/8 inches every, each tick mark is 2, so my accuracy is to the nearest 1 inch, half of the value of the tick mark. Okay, all right, let's do an engineering one. How about we do 1 inch equals 300. Okay, 1 inch equals 300. So I got to grab my engineering scale. 1 inch equals 300. So I got to use the 30 scale. Look for the 3. As soon as I find it, I'll let you know. There it is. Found it. 1 inch equals 300. Okay. First step, what is the value of each of my tick mark? I know there's another 0 at here. So that is, you find the 1 spot. So I know that's 100 feet. I know there's 10 tick marks between here and here, here and here, here and here, here and here. So each tick mark is 10. 10 times 10 is 100. So my accuracy is 5 feet, okay? So 200, 1600, we're not, so each tick mark is 10 feet. So I'm between, so this is 1,690, right? 100, 200, 300, 400. Maybe if I do this, will that help? There, maybe. So yeah, between the 9, because this is 9 tick marks over from 16, and 1,700. So I know if I add, I know my scale is 2 zeros, so if I take this number and add 2 zeros, that's 1,600. Okay? So 1,000, I know it's 600, and then each tick mark is 10, right? 10, 20. So I get to the 90 here, but it's in between. So 5 feet. Okay? Okay, I know this has to end in 5 or 0. All right, so that's the front side. Okay, if you want to put the accuracy here, nice and neat, go ahead, but letter everything. Okay, so that's the front page. Now the back side is, now I want to draw a line that's 15 foot 6 inches. If you look here, it says draw a line 15 foot 6 inches. All right, so I'm going to take a 1/4 inch. So what's that in engineering? 6 divided by 12, I know there's 12 inches. 6 divided by 12 is 0.5. So if I'm in engineering, I'm in 15.5. All right, so 1/4 inch equals a foot. So I got to grab my architect scale. Okay, here's my 1/4 inch equals a foot. So 15 foot 6 inches. So here's my, is this 6 inches? Yes. So I'm going to go to the 15 foot mark. Okay, so what I did, so from the 0 to the 15, right? That's 15 feet. And then I just went to 6 inches over. So there is 15 foot 6 inches. Now if I do 1 inch equals 10 feet, I got to go to find the 1 scale, my engineering scale. Okay, so this is 10, so that means this is 15, right? this is 16, but I want 15 and a half, so that's halfway in between. So I go like that. Did I make sure I did it? Yep. Halfway between 15 and 16. So that's 1 inch equals 10 feet. All right, let's talk about this last problem. And, okay, so you do not physically have to draw out this problem. What I want you to do is the math. This will help you with Civil 3D. I got to figure out what scale I'm doing. Okay, so sketch this out to help you, and then you'll be able to solve it. Problem. The paper size to be used is 17 inches wide by 11 inches tall. Okay, so this is called paper space. So 17 inches by 11 inches. Okay, the north-south dimension of the building is 462 feet. So if I draw I need to draw a building on here. So I know this is 462 feet, north-south, right? This is north, south. The east-west is 350 feet. Okay. All right, so that's the building I need to fit. I need to fit a 350 foot by 462 foot building on here. Okay. The north direction must be at the top of the page. So when I'm drawing this, my north has to be up. So I cannot rotate this object. Okay. You must leave 1 inch margins on the side of the paper. All right. So that means, right, because you got to have a border. Okay, so what does that mean? So that means now my paper space is actually 15 inches, because here's 1 inch, here's 1 inch, 17 minus 2 by 9 inches, right? Because I'm subtracting an inch here and an inch here. So I got to fit this building in this much paper space. What engineering scale will you use to draw the building that give you the largest picture on the paper? All right. So I know I have to fit 462 feet in 9 inches of paper space, right? Okay, because that's my north-south direction and I cannot rotate it. Okay, so what am I going to do? You're going to take 462 divided by 9 inches, right? And you do the math. And that equals 51.33 feet. So now, engineering scale. Do I have a 51.33 foot scale? I do not, right? I do not, okay? So if I use 1 inch equals 50, right? I can only fit what? Okay. Can I drop that down to 1 inch equals 50? So 9 times 50, because right? So I have 9 inches of paper times 50 feet. I can only fit 450 feet, but I gotta fit 462 feet. So that means I gotta round this up to 1 inch equals 60 feet. Okay? So now if I take 60 feet, I can draw 60 feet per 1 inch of paper times 9. That means I can get 540 feet in here. Will that fit now? In between my margins? Yes. Okay? So I'm going to let you figure out the east-west direction and figure out what scale that is, and make sure you figure out that one. Okay? Now the trick is you do not, unless you're doing a cross section, you will not change your scale from going horizontally or east-west to vertical. So I want you to calculate this dimension, okay, which is 350 feet divided by 15 inches of paper. Calculate that scale. What do I have? And then my final answer is I got to pick the larger of the two scales. Okay, so this makes sense. So that is the assignment. I hope it's clear enough. Please sit down with me. If you're struggling, I'm more than willing to help. This is the way I was taught. This is I've been using scales my whole life. I've taken it for granted, so I'm trying to find the best way to teach it. So It'd be nice, typically what we would do is I'd have you sit in here and then we would practice the architect and make sure you're on the right track, okay? So in Blackboard, you go to Learning Plan 3, I'll get the video in here, I have a couple YouTube videos in here which will really help, explain how to use these, plus what I'm going to put in there. Here is, I can just take that guy out of there. Okay, here's your scaling assignment where you're going to submit it. So when you're done writing it all down, you're going to scan it into a PDF and put it in here. Here's the lecture notes. Here's the scaling practice. Here's those solutions I was talking about. Now remember, they may be a little bit different. Okay, they may be a little bit different because of the size of the paper. Okay, so here is the scaling practice sheet. Print that out. Keep doing it until you get close to the same answers as I get. Okay, here's the notes. Here's some more activities that may help you. Okay, I kind of found this here. If you want to go through this, and it kind of goes through it, and it actually has some exercises at the end here, and it gives you the answers at the end. So hopefully between what I'm saying, what you read, what you watch in the YouTube videos, you'll have a good grasp on engineering and architect scales. Okay, so this is due a week from today. So I'm going to gauge to see how people are doing, and maybe we'll extend it, maybe not, or maybe we'll spend another week on it. Okay. So with that, this is the end of my recording. Thank you for being patient. Still learning electronics, so if you can't read it, it's fuzzy. I'm trying to watch the screen to make sure you can see what I'm pointing at, so I apologize if you can't. Just please come see me with questions, and have a great day.